Um, Morning, everyone. Hopefully, you had nice breakfast. Thanks for coming. In this room, we are going to have whole day of hardware management track related presentation. This is the first one where I'm going to go over the overview of hardware management project. But if you are interested in this area, today we have a number of presentations, and then we have sub-project level presentation in the afternoon. There is a panel also, so it's going to be an exciting day of back-to-back presentations. The first one, just quick intro, I am Distinguished Engineer at Broadcom, and I am the co-lead of Hardware Management Project. This project has been in existence for quite some time, and we have been covering other projects. Hardware management is basically central across all different projects. So there is a common piece of that we cover across all different projects, and there's a baseline functionality, and that's what I'll cover, what the actual project deliverables are, what's in the scope, and what's it's covered. Our IC lead, John Liang, is here. John, if you want to just stand up. So in the afternoon, he will be running the track, and then morning, I'm going to cover it. So let me kick off this first presentation. That will give you an overview of the whole project, and then you will see more detailed presentations later in the day. So it's very simple from the charter standpoint. What is this project is about? As OCP platforms, OCP, whether it's a server, devices, there are a number of hardware-related component, system-level specification. When they are in place, hardware management is an essential piece within that. So that's what this project wants to cover across all those OCP projects, cover the common aspect of hardware management. And the idea here, it shouldn't be any surprise, but by doing that, we are going to create interoperability. And that's where you'll see some of the areas around OCP profiles, some of the templates we have defined. There are some presentations later on which will cover about the internal facing interfaces. So it basically provides a common foundation. That's what this project is about. Its motivation as we started growing in the scale, this project was more than 5 years ago, it was realized that we need to have a separate project which focuses on this. And it not only creates all this profiles and specification, but also looks into from the tool standpoint, what are the conformance aspects? And I'll cover some of that for the OCP profiles today. So that was the motivating factor behind this project. This one, what's in the scope? All the things you can think from the manageability standpoint, it's within scope. BMC requirements, we have conformance, interoperability, and the platform management, that's the focus. There is also guidance and feedback to other projects we provide. We have this whole profile repo that we oversee from the hardware management project side. And there are 3 sub-projects. Used to be 4. We recently merged the rack management controller and device manager. Those 2 became 1. This is where at the rack level, the specification, both northbound and southbound interface, as well as how you manage the device asset and inventory. So I'll cover that. And then we have other sub-project called hardware management module sub-project. This is where specification for BMC from the standpoint of standardizing, decoupling it from the platform, defining run BMC specification, which allows one to build a BMC based on the pin and the connector specification. And then also we have this DCSCM, which is the secure control module within the hardware system. And there is a 1.0 spec, and now we have published a 2.0 version of that, which basically provides all the security and manageability aspects of the data center. And then we have a project in incubation called hardware fault management. We have a number of presentations about what it is covering. The idea is we want to standardize the common way of reporting the hardware faults, and also ability to use the standard fault provided in a format that can be consumed by higher level management application. So that's, if you see, that's the overall scope of the project, and there are 3 sub-projects within that, as I mentioned, and I'll cover them in more details. And I don't see, we have, just to mention, for the rack management controller and device manager sub-project, we have Han from Meta, who is the sub-project lead. I don't see him here, otherwise I would have asked him to stand up. And then hardware management module sub-project, we have Eric Shobi and Shan, 2 sub-project lead, and hardware fault management, we have 3 project lead, Rama, Zenyu, and Yogesh. Recently, device manager, as it merged, we have another project co-lead there to help Han message. So volunteers are very active in this sub-project. Each such sub-project has its own meeting. Some are meeting on a bi-weekly, some are weekly, and project meetings are happening every month. So with that, first let me go over what we have already published and accomplished. So from the profile standpoint, what this, when I talk about a profile, what it is it's describing a management domain-related requirements for specific management features. And it's all based on Redfish. OCP works very closely with DMTF. John and I and other people, we have been working in both organizations, so that does help to create this kind of synergy between those 2 organizations. You can think about DMTF basically provides the spec, and then prescription is coming out of OCP. That's where the whole baseline profile 1.0 version was released. Now, that 1.0 version basically covers across all the platform, what is the baseline functionality. Then other projects can take those, and then they can have their own derivative based on the specific project, like server has its own profile. So that's co-owned with the server project. And there are other projects, they can do the same thing. I want to mention, now we have moved to this usage guide, basically for all the profile spec. What used to be previously what we publish as profile specification, those are obsolete. So those who were familiar with what was published before, I just want to mention that. So that's on the profile side. On the hardware management module side, we have Run BMC, which is the daughter I/O card specification that's been published, and then DCSCM, both 1.0 version and 2.0 version. OpenRMC is similar to profile. It has its own usage guide for the not-bound profile. The design spec is also released. And similar to profiles, there were previously we released those as API specification and profile specification. Those are obsolete now, so primarily you should focus on looking at the usage guide and design spec. So these are already published documents. And you can go on hardware management wiki page and find all this, and you can also from there go to sub-project, their wiki pages, and find all the published specs. So let's first start with what do we call when we say the OCP profile. So what is this? It's derived from Redfish specification. It defines in the profile what you have. In the profile structure defines a set of features that are applicable to a given platform. So for baseline functionality, we have the features which are applicable to all platforms. So that's where the inventory, temperature reporting, power management, they come into picture. And if you see this structure, over the years we have spent significant time. First we had the baseline profile, then we worked with other projects. Server project being one of them, where server specific profile will be leveraging what's in the baseline functionality and will be deriving additional features on top of that. And that's how you do the extension. And the idea behind this is all of this, if you have a Redfish compliant client, all this can be exposed as service, and then you can interface and then check for specific profile conformance on a given platform. You can expect certain set of features to be existence there. So it helps with developing the management application. So that's on the Redfish-based OCP profiles. As I mentioned, I'm not going to go into details of this, but you can look at one of the profile. But general structure of profile is, this is where it defines all the requirements. So what resources need to be exposed, what are the actions, if there are any, and if there are events or anything, then registry-related requirements. That's how a profile will look like. Examples here, for example, if you are exposing Ethernet interface, or for hardware inventory, you want to have asset tag as one of the property in there. So that'll be contained within the profile. And then those are the required properties. So an implementation which is compliant to that will be exposing those required properties as well as required actions. So if you are an end user, you really don't need to worry about knowing the structure of this profile. It's mainly for the implementer of that service. But from a client standpoint, you just look for the conformance to that profile, and you can expect the set of features to be existent. So that's how the OCP profiles work. And then, as I mentioned, they are based on the standard Redfish base, so any Redfish client you can use to do the management functions on a given platform. A little bit more on tool here. As I was saying, DMTF and OCP, they work very closely together. So DMTF, that's where all the specs, Redfish specification has been developed by DMTF, and it's been enhanced as more and more functionality being added. Redfish at this point pretty much covers all the aspects of data center management, and now we are getting into even the DSIM and the cooling and other aspects. So it has really grown over the time. So from OCP standpoint, we are leveraging those specs. And what OCP does is the prescription. That's where the OCP profile comes into picture. While doing that also, we are leveraging a set of tools that are open source, published by DMTF, available to everybody. So the tools that are listed here, you can think about what. First one is the service. This is where you can check for the conformance of service to the Redfish specification. So that is a validator tool for that. There's also the protocol level validation. There's a tool for that. You can also check for the profile interop, and then there is an interop validator tool for that. And then recently, we also talked about different kind of use case. So if somebody is interested in saying, I have this implementation, whether when I do one-time boot control or power control or inventory, is it conformant? So there are a bunch of use case checkers. That's what that tool does. That allows you to check for those kind of use cases, whether a given implementation is compliant with that. So as you can see, there is this synergy now that from description all the way to the testing and implementation between DMTF and OCP, you have a common manageability feature set as well as tools. You can go and look at all, these are all links that are here. So if you are interested in it, you can go and look at and try it out. And it's also on our wiki. From there, you can also go. So that's one of the big piece within the hardware management project, all the profile, specification, conformance, that's being handled at the project level. Now let me get into the sub-projects. So the first one I'm going to talk about is OpenRMC, Rack Management Controller and Device Manager. They used to be two separate sub-projects. Recently, they merged into one. And there was synergy because they both were trying to do things at the rack level and then at the data center level. So what the RMC project focuses on, if you think from rack management standpoint, it defines that rack management controller function and then interfaces to that. And then interface from the northbound side where a client can directly talk to it, and it can also use the southbound interface to talk within the components within the platform. And there's already an open source implementation out there of the RMC. And then device manager architecture, this is for, if you think from, if you treat different nodes or systems as the devices that are being managed by an entity, this architecture basically is leveraging redfish-based management for some of the key functions that you typically do in data center. So these two sub-projects merge into one, and now together they are covering the rack management as well as device management. A little bit more on the RMC part. This is how that architecture looks like. As you can see, a client uses northbound. This is where RMC profile comes into picture. It's redfish based. The compliance of that can be tested, and client can use that API and REST style interface to talk to rack management controller. Via that, the RMC then will talk to the specific system, so it's a hierarchical. That's where it will use, for example, we talked about server profile to talk to the BMC to do the functions it want to do on a specific server, whether it's a power control. Let's say from the client side, you want inventory of all the hardware that's out there. So the way this will work is from the client, you go through RMC. RMC will talk to individual servers, BMC get those inventory data, and then it will propagate that to the client. So as you can see, this is how it's layered. There are different components that it touches on. So within server, it will touch the firmware level component, BMC firmware, all the hardware inventory, and the rack level, you have the RMC typically implemented via this RMC firmware. And there's also a repo for rack manager source. So that's the OpenRMC architecture. The features it covers today, inventory, power control, power utilization is very important from the data center management standpoint. So the features that are defined, it allows you to monitor the usage of power within the rack. Also, you can put the limits so that if it exceeds power, you can apply the policies to either power down system or maybe lower the clocks, bring the power down. And then just from the diagnostic and monitoring standpoint, there are use cases where you want to continuously monitor the temperature. Based on how the temperature or heating happening inside, you may want to take action. So that's where the temperature reporting comes into picture. Firmware has been one of the key component across within the system as well as on this kind of rack managers. Everywhere you see different firmware component. And having the ability to inventory what firmware versions are running on all those, also having the ability to update those is very important from the management standpoint. So this includes all the servers and devices. So that's also one of the key feature of OpenRMC. And then finally, you want to have just overall health status. This is where you can think about your red, green, yellow. Within a rack, one of the server may be malfunctioning, or you may want to see whether it's in a warning state. So underneath, there are a lot of data that is available, but they can be all aggregated through this interface, and then you can provide the overall health status to the client, and that's how you can manage. So that's OpenRMC. Device manager, this is more or less focused on you have a manager that is looking into the data center and looking at all these devices and really looking at from the hardware standpoint, firmware, the monitoring and control aspects of that. This project, sub-projects, as I said, started and then it got merged with RMC. So the key aspects here are the inventory, asset management, monitoring and control, and manage all the software and firmware updates. So there's a lot of synergy with what OpenRMC was doing at Device Manager. So now this is all under one umbrella. So that's that sub-project, OpenRMC DM. The second sub-project is hardware management module. So this was primarily focused on coming up with an interface. You have this system level management module, how it fits into the underlying platform, and if you have a standard way to interface with it. And to go along with that, there are the design spec, design guidelines, and reference architecture. So that's what this sub-project has been working on, and that's what they have published. So the two key set of specs here are Run BMC and Data Center Secure Control Module. Those are the specification coming out of that sub-project. If you think about Run BMC in the past, if you have seen the presentation, what it did was it basically standardized the connector from the server management aspect. So you can, using that spec, you can build any BMC module which will plug into any platform which supports that. And this basically allowed one to decouple the BMC module from the platform, and that still you can interoperate as long as you are compliant with what that spec defined. And that covers all the connector pinout, the different form factors can be also supported using that. So this is a spec. We have already existing implementations. People have provided the reference architecture. Similarly, data center secure control module specification. This is within within the server, you have a secure control interface, how you can use that, including the root of trust. And there is a spec which defines that. As long as you comply with that, any implementation can be used in a given platform. And it started, and then it has revved it to now 2.0 version. We will have several presentations to describe some of the details of that spec. So that is hardware management module sub-project. And the last one, hardware fault management. This is the sub-project. We had I think last year, or yes, it was last year, we had this panel. It was a very interesting panel. Everybody is very interested in looking into different architectures have different hardware level fault management. The formats are different, the reporting structure may be different. So there is a significant interest in coming up with a common way of describing these hardware level faults and common way of reporting those. That's what this sub-project is focused on. And those are the interfaces and standardizing. What is the behavior? Like, for example, you get something, a thermal event from CPU. Basically describe that behavior. What does that fault, how does it look like? What is the format? How do you manage these kind of errors? So that's what this sub-project is focused on. We do have also a panel later today where we'll see some interesting discussion on this area. So in summary, I went over the overall hardware management project. Its focus is basically common manageability across all OCP platform. Within that, we have 3 sub-projects: OpenRMC and Device Manager, cover the rack level management and devices within data center. Then we have this hardware management module, which covers the BMC and DCSCM kind of specification, so that you have a compliant implementation which can plug into any platform. And then we have recently this hardware fault management sub-project in incubation. So very exciting work going on in the project and sub-projects. My call to action to you guys, take a look at what's been published. There's a lot of things that we still need to do. Come to the project calls or sub-project calls, contribute to the spec, contribute any reference implementation. If you have any questions, come talk to me how to get involved with these projects. And if you are from other projects, we should also, if you are looking into some kind of how do we collaborate on defining the platform specific management and how do we derive from the baseline functionality we have already created, we can discuss that. So with that, I'm going to stop here and take any questions. And there are 2 mics, so if you have any questions, come to mic and raise your question. Yeah. Yes.
I'm Panos Christeas from Meta. We had a presentation yesterday about the CSM, the cloud service model, and I'm just calling you to collaborate because we are doing a complementary project on how this information from the first level of redfish collection will scale up in data center size and will be also available to vendors. So that's a very good chance for us to collaborate and see how this thing that you are providing through the hardware control in the first layer will be usable and we will exploit its value in the higher layers.
Yeah, excellent comment on this. So yeah, that'll be great. Let's talk offline on how we can collaborate. But the idea is to move up to this layer. And if you see some of the RMC and device manager, that's what
we do have an FTI working group on that, so we can cross our work
Sure.
either on the hardware management group or there.
Yeah, and we can schedule a meeting or where we can talk about this. Thanks for bringing it up.
Just to add a comment, like
Yep.
yesterday, we went to that forum and we interacted. I am from hardware fault management project lead from Microsoft. I'm Rama. Like we are trying to talk to them and see like what are the avoiding duplicate work, okay, and how we can collaborate each other.
Yeah, that'll be great. So as I mentioned before, Rama is one of the sub-project lead for hardware fault management. Let me see if I have any of our sub-project leads here. Okay, we'll introduce them later. Okay, any other questions? Okay, thank you. Oh, go ahead.
Question, like how do you see the adoption of OpenRMC? Because I've seen some implementations like where they're trying to make the BMC as the do the functionality of OpenRMC, try to deprecate that feature because it's adding cost. Where do you see the value of it and versus where it doesn't provide value?
So good question. And John, feel free to chime in more if you have a comment. But we did have reference implementation being submitted. It's basically whether it boils down to how much of this kind of hierarchical management you want to do. There's always a way to directly go to and talk to BMC all the way from your client. But I think that aggregation of function by RMC does make a difference for some of the clients. Go ahead, John.
When we started OpenRMC, we actually, one of the actual goals was to provide the actual source code for a rack manager. And one of the value propositions is that the original redfish and the redfish model was targeted toward BMC, replacement of the BMC, which is running IPMI. You do a firmware upgrade and you're running around BMC. So the functional possibilities within the BMC are limited. As we add additional functions like composability into the redfish model, aggregation, the amount of processing power necessary is steadily going to decrease. So if you're using the BMC to aggregate reset, right, that's fairly easy. If you attempt to use the BMC to do firmware update across the entire rack, it gets much more complicated. Right. Requires more memory, requires more compute power. At that point, you have to go pivot from a BMC to something bigger. Yesterday at the FTI presentations, they were talking about the in-band management agent, which is exactly that. At some point, the BMC is no longer big enough, and you have to go pivot to something much larger. And the way OpenRMC was defined was it defined an interface. It's implementation agnostic. So you can implement it on a switch, you can implement it on a standalone server, you can implement it on something on the backplane. So.
Yeah, and as we move up to like higher level policy
Yes.
kind of management, that's where this really makes sense because you may want to have some compliance check across the rack. Where the rack manager controller makes sense.
Yes, yeah, definitely. Thank you. I think one thing what we observed comparing the two implementations is like sometimes it provides value, sometimes it is providing like a choking point. Let's say if you want to push the data,
Right.
like from, like say your rack, like 40 blades or something, every data has to go through OpenRMC. That adds, there are some use cases for both. Some adds value, some adds like dependencies. Yeah.
So I think that's interesting. I mean, nothing in there that prevents a client implementation to have hybrid where it can go through RMC and as well as talk to BMCs directly. Because
That will
end of the day, it's a Redfish compliant
Yes.
service.
Yes.
So
And I would greatly invite you to the OpenRMC discussion because
Yes.
that's exactly what we need. One of the first learnings from OpenRMC where we had a whole bunch of vendors come in and we found that at one end, they wanted a full abstraction
Right.
of OpenRMC. They said, we don't want to see what's underneath it. We want to abstract it away. We just want to reboot. At the other end of the spectrum, they said, we don't want that. We want the reset button so we can reset it. So it'll come up, the OS will come up and we can talk to the agent because we really don't care at the bottom. So we really don't want any abstraction. We want to be able to designate which server we reset so we can go talk to it.
Right.
So it was trying to reconcile this very disparate idea of what should be a rack manager. So your voice is definitely.
Yeah, it'll be good if you. Okay.
Just because of this talk, I want to throw a buzzword to start thinking about composable BMCs, like being different parts
Right.
in the system, being the RMC, the BMC, and in-band, and combining all of those together to achieve the goal of managing the devices. So we could start designing composable BMCs then.
Yep. And that provides you the logical abstraction.
So I invite you to my discussion, my session at 9:10, where we will actually talk about the original contribution of Device Manager, which actually had both an out-of-band BMC and an in-band agent all on the same switch.
Yep.
And so it was
So
all
that's
envisioned
coming up.
and implemented and actually donated to OCP.
Yep. Thanks, John. I think we have still time for questions or any discussion. This is our next talk is at 8:50. Okay, if not, then we can all sip our coffee for next 15 minutes. Thanks, everyone.